Remote monitoring of birds has gone on at, migrating birds has gone on at the survey for a long time. And there are people that work with radar. But to get information on individuals, you need radio transmitters. And radio transmitters were pioneered at the survey. Radio tracking animals, the first one was a bunny on the quad. And then migrants, we started to follow those in the 70s. We have several types of transmitters I'll talk about today. We can modulate them, so we can have units on them that gather information, and we can have microphone transmitters, heart rate transmitters, and altitude transmitters. And they're affixed to the backs of small migratory birds. Larger birds, we use harnesses. And they don't weigh very much. You can get the information by following a bird flying through the night sky with a car or a plane. And it's basically line of sight, so the higher the animal is, the more your resolution. There are 2 traces up there of migrants that I followed this last spring. And you can see that the dashed line, that's my path. And sometimes you can be quite a ways away from the animal. These animals had microphones on them. And this is the kind of data that you can gather from a microphone transmitter. And I'm a little off kilter here. We also have heart rate monitors, and the heart rate monitor will keep track of the bird's heart rate and wing beats during the flight. And so you can get respiration rates from that too. And this is a paper published about 6 years ago by Wilkowski et al. And it shows the physiology of a migrating bird. The bird's heart rate is 10 hertz or 600 beats a minute resting. This is a transmitter that we're currently using, an altitude transmitter. And it basically is an altimeter. It gives you pressure and temperature every 15 seconds. And then it's been calibrated so you can trace the bird's altitude. This is a bird that went from Champaign to Moline. And we were very intrigued by the changes in altitude, 600, 700 meters down to 300 meters. And we think that might have to do with light pollution. We also have devices to monitor many animals at once. And the first way that I'll talk about doing that is with microphone arrays. So these are transmitted recordings that go back to a single antenna, and then that's all synced in a computer. And so we have precise, exact synchronization of calls. And we can get height, vectors, and ID because we know the bird's calls. And for that, we need supercomputing. So I'm working with the supercomputing people on campus to get these data. This is an example of just a single call of a bird, and you can see how it's shifted in both frequency and time. And using that, we know that it was 350 meters up. It was headed north-northwest, and I can't remember the speed. The other thing we're doing with multiple migrants at the same time is a project looking at gulf crossings. And we have birds that are tagged with radio transmitters in Mobile, Alabama, and then they cross the Gulf. We've covered the Gulf with a radio fence, and they're twin Yagis, highly directional, and you can see the coverage there. And with these data, we can model migration much better than before. Most of the models before basically assumed birds were particles, and now we know what their behavior is, their adjustments. The other little figure up there shows hits on the coast, and from that we can start to predict how dangerous it is to cross the Gulf. And these are all the people that work on this kind of stuff and some of the institutions we work with. And that's Arlo Rame, who was involved many years with migration and with tracking, and Arlo passed last year. So thank you very much.